Hello and welcome to this video on how to calculate the resolution of peaks in HPLC chromatograms. When using HPLC, it's useful to have ways to measure the efficiency of the system, especially to monitor how it changes over time, in case we need to replace the column, for example. Efficiency can be defined as the ability of the HPLC system to separate the components of a mixture. We usually use resolution, or RS, as a measure of efficiency. Resolution has two parts: the separation of the peaks, or how far apart they are in the chromatogram, and the peak width. Peak width can be measured at the base of the peak, which we call WB, or at half the height of the peak, which we call WH. For Gaussian or symmetrical peaks, resolution is defined as the distance between the peaks divided by the mean of the peak widths. The distance between the peaks is calculated using the difference in the two retention times. The mean peak width is calculated in the same way as any other mean. Because this equation contains something divided by something divided by something, we can rearrange it to RS equals 2 times the difference in retention times divided by the sum of the two peak widths. Let's look at an example calculation. To calculate the resolution of the two peaks in this chromatogram, we need the two retention times, which we can read from the scale, and the two peak widths, which we can also measure from the scale. We use these values in the equation and calculate that the resolution of these two peaks is 1.2. But what does that mean? What values count as good or bad resolution? We're usually aiming to achieve baseline resolution, or better. This means that the peaks are separated completely, right down to the baseline of the chromatogram. For Gaussian peaks, this requires a resolution of 1.5 or more. Strictly speaking, this is only true when the two peaks are the same intensity. However, it's a reasonable approximation in other cases too. Resolution values between 1.0 and 1.5 are usually considered acceptable, as a resolution of 1.0 corresponds to an overlap between the peaks of approximately 2%, which is considered acceptable for quantitative calculations. Conversely, resolution values below 1 mean that the peaks are overlapping significantly and are not suitable for use in quantitation, as the degree of uncertainty is too large. Values above 1.5 still give complete baseline resolution and just mean that the peaks are getting further apart. If we look at the equation for resolution again, we can see that as the value of RS increases, this must either mean that the difference in retention times is increasing, or that the peak widths are decreasing. But either way, the peaks are more separated from each other. Thanks for watching, and look out for more content coming soon on the Analytical Science Tutor channel.